Hi, today we're going to discuss Rolle's theorem, and this will continue into another video about the mean value theorem. Really the kind of focus of this section. Something really good to understand here. Rolle's theorem isn't that bad. It sounds tough here, but once we take a look at an example problem or two, you'll find that it's pretty straightforward. So anyway, let's read it together and then look at kind of a generalized question and then something more specific. So we got a function f. It's continuous on the closed interval from a to b and differentiable on an open interval from a to b. Can't be differentiable on the closed because what if it just stops there? So it's not differentiable at the end point, but not a big deal there. So if f of a equals f of b, there's generally some confusion here. We'll talk about that in a second. So if f of a equals f of b, then there's at least one number c that's located in the interval ab such that f prime of c equals 0. Sounds super mathy, but let's actually think about what that says, okay? I have myself a function, okay? And we have a right here and b right here. Just two generic locations along the x-axis, and they have to have y values, okay? And so the function has to have, f of a has to be the same value of f of b. So if this is the y value, okay, and then this one has to have the same y value. That's all this first part's saying, other than it has to, this point has to connect to this point continuously with no sharp turns or any weird kind of thing. So it's going to look like a very typical normal looking function. So this point is a, f of a, this point is b, f of b. So it's an x value and a y value, and they're connected. We don't know how they're connected. Let's just do this. It could be a straight line. It could wave like this. What we know is it's not going to be like a V shape or anything else like that. So f is continuous. F is differentiable. The y values are the same. So that means there's some value in between a and b where the slope of or the derivative of c is 0. So think about that. All they're saying is, see that red line? That red line slope is f of b minus f of a over b minus a. Just using some algebra 1 here. So if I were to use the slope formula, I'd say, oh, well, this value and this value are, the y values are the same. So that's 0 over two different numbers, whatever b and a are, and so my slope is 0. They're saying, hey, isn't there somewhere in between these 2 points that also has the same slope? Well, sure. Hopefully you can understand that at right here and right here, we also have the slope of those tangent lines being 0. And so we would call this one like C1 and this one C2. You're guaranteed at least one C value, not only one C value. So once again, basically we're looking for slopes or derivatives that it can be equal to 0 somewhere between those 2 points. So for instance, let's look at an example problem, something very specific. And so here I have f of x. We see it's quadratic, and we want to know whether Rolle's theorem can apply, and if it can be applied, find the value in between 1 and 4 that has a slope of 0. So what we're going to do, first of all, you should hopefully know that this is continuous. You should also know it's differentiable, so we know that. Okay. Continuous on from 1 to 4 and differentiable from 1 to 4, closed interval. Okay. And so what I need to do is I want to find f of 4. So no calculus yet. So f of 4 is going to be 4 squared minus 5 times 4 plus 4. That's what? 16 minus 20 plus 4. Oh, that's 0. Okay, that's kind of weird. And f of 1. better also be 0, because if not, that means f of a and f of b are different values. So if I put 1 in there, I get 1 squared minus 5 times 1 plus 4. That's 1 minus 5 plus 4. I get 0. Okay. So f of a and f of b are the same. So what they're saying is, hey, what value exists between 1 and 4 that also has a slope of 0? Okay? Because these two guys are the same y value, kind of going back to this, because they have the same y value, if you connected them, that's a slope of 0. So, now I'm going to take my derivative, f prime of x, 2x minus 5. Now we want to know when this derivative equals 0. Okay, so we're going to do 0 equals 2x minus 5. We're going to add 5 to both sides and then divide by 2. So when x is 5 halves, notice if 5 halves is in the interval, that's my c value. So it falls in the interval there. So this is the value. This would be my c value. And so f prime of 5 halves equals 0. Okay. I'll do another video with a different example, okay, just to kind of highlight this once more, and then we'll move on to mean value theorem.